Hi guys, this video today is going to talk about inverses, and we talked last time about how logs and exponents are inverses of each other. That's important for us to remember today as well. Last unit, before spring break, we talked about composition of functions, and that's when you plug one function into another. Remember this little dot? That is not a multiplying sign, that is a composition sign. So what we're going to do is we're going to plug g of x into f of x. That's for this first problem. So here's my g of x. I'm going to plug that in for the x value here. And so f of g of x is going to be 3 to the power, well, it looks kind of odd, but it's 3 to the power of log base 3 of x. Now, what is interesting is we talked about a couple times logs and exponents are inverses of each other. We also talked about last unit, we talked about, well, what happens when you have a composition like this and you simplify it. And so that's our second step, is to simplify this. Well, if you simplify it, if they are inverses, do you remember? They're supposed to cancel down to x. And that actually is what happens here. This 3 to the power and this log, powers and logs are inverses. They cancel each other out. And all we have left is an x. Let me try to explain that maybe one other way. So let's say, up here I didn't have anything over here. Let's say we have, say that's equal to y. Okay, let's say we do something like left, right, left. So for left, right, left, right now this is an exponential, which I know seems kind of weird. How's that exponential? Because it's an exponent. But let's go over and change it to a log. And so for left, right, left, we're going to do log base. Well, the base of this is 3. And now we're going to go to the right of y is equal to left, log base 3 of x. Okay, so if this was an equation, we have a lot more work to do with equations. We haven't talked about equations, but can you kind of logically see that these are going to drop off? And so we have y equals x. Well, what's y? Y was f of g. And I just used the other notation accidentally, but that was the other notation. And so f of g of x is x. And so these cancel each other out. The exponent and the log cancel each other out, and they leave you with just a plain old x. Let's try it again. Let's say we go the other way. And so this time I'm going to take f of x and plug it in to g of x. So I'm going to take f of x and I'm going to plug it in to g of x. So I'm going to have log base 3 of 3 to the x. Well, once again, logs and exponents cancel each other out. So this actually reduces down to an x. Let me use that same logic I was doing over here to maybe explain it a different way. Let's say that g of f is actually y. Okay, so I rewrote it down here. I said instead of g of f of x, I'm going to call that y. And that is my original equation. So if I go left, right, left, or right, left, right, this time I have a log. I want it to be an exponent. I'm going to go right, left, right because of the way I wrote it out. For this, changing it into an exponential, I start with the base. I start with the 3. I go to the other side, 3 to the y. I go back to the other side, and that's 3 to the x. So again, kind of logically, can you see that these 3's are going to drop out of this equation, and they're going to give me y equals x? Well, y was g of f. And I said that that reduces to x. And now I'm kind of proving that. The main thing I want to get at here is if you have two functions, one is a log and one is an exponent, if they are inverses of each other, then when you plug one into the other, they cancel out to just a plain old x. We learned that in the last unit. The new part today is it works for logs and exponent. As long as the base is the same, this is a 3, this is a log base 3. This is a log base 3, this is a big 3. So it's going to work the same way. Let's do another example. This time we're finding the inverse functions. And maybe before we move on to this, let's write this in the margin, that logs and exponents are inverses of each other, and so they cancel each other out, because that's an important point for you to remember. Okay, in the last unit, we talked about how to make inverses, how to find the inverse. And the first thing you do for that is you switch your x with your y. And then you solve for your new y. So we're going to do that. We're going to switch the x with the y. Remember, f of x is like a y. I'm going to turn that into an x. On this one, I have an x. I'm going to make it a y. And now I need to solve it. Remember, when you solve it, you have to do PEMDAS backwards. You do PEMDAS backwards, so that means you have to start with your adding and subtracting when you're solving this. So I subtract my 2. Next thing is I do have a negative there, so I'm going to divide this side by -1, and I'm going to divide this side by -1. And so that's going to give me a negative x plus 2 is equal to a positive 4 to the y. I just didn't like that negative being over there. I'm trying to solve for y. That means I need to get the y by itself. In order to get that y by itself, I'm going to have to go right, left, right, and turn this exponential into a log. So I'm going to say I'm going to say log base 4. That's this one right here, log base 4. I'm going to go to the other side and say negative x plus 2. Then I'm going to go back and say that equals y. I am now finished. I want to rewrite my answer so that you can see what it means. Let's take a second to kind of look at this new equation. First of all, I rewrote it so that we have f of -1 of x over here. Remember, that's our notation that means inverse. That -1 power means inverse. Next, I want to compare what we came up with an answer to the original question and make sure it makes logical sense. So one thing is, everything should be opposite of each other. So this was an exponent, this is a log. But this is base 4, this is base 4, so we're good there. Now, this was a plus 2. This is still a plus 2, but remember, the reason that that was a plus 2 is because we divided by that negative. So we have this negative here and a plus 2 here. I guess another way we could have written this is we could have written this like this, where we have the -2 and the positive x with the -1 out here. But the negative, that's where that comes from. The plus 2, we had to switch signs, so it's still a plus 2. But this is our answer. This is going to be our inverse function. You just have to basically undo all the other stuff to come up with your new function. Let's do one more example of that. This time it is a log, and so the inverse must be an exponent. So I'm going to switch my x with my y. Now I'm going to solve this, and I'm solving it for y, so I have to isolate my y, so I'm going to subtract my 7, doing PEMDAS backwards. Okay, now I have a log. I need to undo the log. To undo my log, I do exponents. So I'm going to change this over to an exponential. The base is base 5. So I'm going to say 5, other side, power of x minus 7 is equal to this side, y minus 3. I had made a mistake. This was supposed to be a y minus 3, not a y minus 5. So if you can make sure that's correct on your paper, that's a y minus 3. Okay, again, to do that, I went right, left, right. Right was a 5, left, right, right, left, right. That's where that's coming from. Now, the only thing is I still need to get that y all by itself. So now I need to add that 3 to the other side. And when I add that 3, I'm not adding it to the 5. I'm not adding it to the 7. It is its own thing. So I tried to make it big enough where you can kind of see it. The 5 of it is its own thing. This 7 is its own thing. And this plus 3 is its own thing. And so the answer, we were asking actually g of x for the inverse of g. So the inverse of g of x is 5 to the x minus 7 plus 3. And that's it. Okay, once again, there are summary lines down here. Feel free to summarize if you want to summarize things from this page. On the other page, I forgot to put summary lines again, so feel free to summarize whatever you need to summarize from the past couple of lessons on these lines.